In this video, we're going to talk about trigonometry in terms of right triangles. Trigonometry literally means the study of measuring triangles. So we will be dealing with the relationship between the lengths of the sides and the measurements of the angles. Now, one way to study trigonometry is through the use of right triangles. A right triangle basically is a triangle in which one of the angles is a right angle. And then for this particular right triangle here, let's call this side as side A, this side as B, and then the hypotenuse or the longest side as C. Okay. And then lastly, let's call this angle here angle theta. Now for similar right triangles, in other words, right triangles that have the same angle theta here, let's say right triangles where theta is 30 degrees, or right triangles with theta equal to 45 degrees, so on and so forth. The ratios between any two sides are constant. Okay, in other words, for example, if we take this particular right triangle here, the ratio between A and B is equal to the ratio between the corresponding sides on a similar triangle. Okay, and since these ratios are constant for similar triangles, they are defined using what we call the trigonometric functions with respect to, say in this case, angle theta. So first, we have the sine function. Okay, so sine of angle theta in this case is defined as the ratio between the opposite side and the longest side, or the hypotenuse. Cosine of angle theta is the ratio between the adjacent side A and the hypotenuse C. Okay, and then tangent is the ratio between the opposite side and the adjacent side. The last three trigonometric functions are just the reciprocal of the first three trigonometric functions. Okay, so for sine function, its reciprocal is the cosecant function. Okay, since it's the reciprocal, then it's defined as the ratio between the hypotenuse and the opposite side. Okay, reciprocal of the cosine theta is secant theta. Okay, and it's defined as the ratio between the hypotenuse and the adjacent side. And then lastly, the reciprocal of the tangent function, we have the cotangent function, and it's defined as the ratio between the adjacent side and the opposite side. Alright, so just remember, SOHCA, TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Next, another concept that we need to know, of course, is the Pythagorean theorem. Okay, it states that the square of the longest side, or the square of the hypotenuse, is equal to the sum of the squares of the other two sides, right? Now let's solve some problems that involve finding the values of trigonometric functions. These types of problems will require us to find the length of one missing side, and then from there we solve for the values of the trigonometric functions of, say, angle theta. So first, we are given this triangle. Let's call the missing side B. Okay. For example, this side here is A, and then this side is C. Okay. So we are asked to find B and the 6 trigo function values of angle theta. So first, let's solve for the missing side. To solve for the missing side, we need the Pythagorean theorem. So we have c squared equals a squared plus b squared. Isolating b, we get b equals square root of c squared minus a squared. Okay, and then let's plug in the values. C is 5 squared minus a is 3 in this case, so squared. Now b is equal to square root of 25 minus 9. So b is square root of 16. Okay, therefore b is 4 units. Now let's solve for the values of the 6 trigonometric functions, in this case with respect to angle theta. Okay, first we have sine of angle theta. Sine theta is defined as the ratio between the opposite side and the hypotenuse. So opposite side is b. Okay, again relative to angle theta, opposite side is b, which is 4 divided by the hypotenuse. So hypotenuse in this case is 5. So this is sine of angle theta. Next, let's solve for cosine of angle theta. So cosine theta equals adjacent over hypotenuse. So relative to angle theta, adjacent side is 3 units divided by the hypotenuse again is 5. So that's cosine of angle theta. Next, we have tangent. So this is defined as the ratio between the opposite side and the adjacent side. Opposite again is b. B is 4. So 4 over the adjacent side, which is 3 units. So we have 4/3 for tangent of angle theta. Next, let's solve for cotangent of angle theta. This is just the reciprocal of the tangent value. Okay, so 3/4. Okay, and then we have secant of angle theta. Secant is the reciprocal of cosine. So we have 5/3. And then lastly, let's solve for cosecant of angle theta. Cosecant is the reciprocal of the sine function. Okay, so sine in this case is 4/5. Therefore, cosecant is 5/4. Okay. Next problem. So given this triangle, let's solve for the missing side and the value of the 6 trigonometric functions. Let's say we call the missing side, in this case, the hypotenuse C. So this side is A, this side is B. Okay. So required, we have C and the values of the 6 trigonometric functions. In this case, theta. Okay. So notice this time we base our calculations on this angle here. Okay. First, let's solve for the missing side, side C. So again, Pythagorean theorem, C squared equals A squared plus B squared. Therefore, C is equal to the square root of A squared plus B squared, where A is 2 and B is 4. So we have here C equals the square root of 4 plus 16. That's square root of 20. Okay. And 20 is 4 times 5, where square root of 4 is 2. So this can be simplified as 2 square root of 5. Okay. So C is 2 square root of 5 units. Now let's solve for the trig function values of angle theta. So first we have sine of angle theta. In this case, we have opposite angle theta is 2. So plug in 2. Then hypotenuse is C, where C is 2 square root of 5. Okay. So simplify, rationalize, we get what? Cancel out 2 and then rationalize. So this is square root of 5/5. Okay. Next, cosine of angle theta. Cosine is adjacent over hypotenuse. Adjacent to angle theta in this case is 4. So plug in 4 divided by the hypotenuse, 2 square root of 5. And then simplify, we have 4 divided by 2, that's 2. And then rationalize. So we get 2 square root of 5/5. Okay, next, tangent of angle theta. Tangent is the ratio between the opposite side and the adjacent side. So 2 divided by 4, that is 1/2. Okay. Next, we have the reciprocal uh, trigo functions. So reciprocal of tangent, that's cotangent. So reciprocal of 1/2, that's 2, right? We have secant of angle theta. Secant is again, it's the reciprocal of the cosine function. So we have here 5 over 2 square root of 5, reciprocal of this value here. Then just rationalize, we get square root of 5 over 2. Okay, again, this is the result of rationalization. All right. Lastly, we have cosecant. Cosecant is the reciprocal of the sine function. So we have here for the sine function 5 over square root of 5. And rationalizing, we get square root of 5. All right. Now for the next problem, what if the given is the value of one of the trigonometric functions? In this case, we are given cosecant theta equals 7 over 5. To solve this problem, we need to provide a right triangle. Okay, so let's draw a right triangle. We can place theta here, okay, or here. Regardless where you put theta, the definitions of the trigonometric functions will remain the same, okay? And the placement of the lengths of the given sides will just follow accordingly, okay? So if this is theta and cosecant theta is 7 over 5, where cosecant is the ratio between the hypotenuse and the opposite side, okay? Therefore, this is where we put 7, okay? The hypotenuse. And then the opposite side, so opposite angle theta in this case is this side. Therefore, this is where we put 5, okay? Or if we put theta here, then the hypotenuse will still be here, okay? However, the opposite side will change, okay? So if this is where we put theta, then the opposite side of this angle is this side, okay? So again, if this is where we put theta, then we put 5 here. Alright, so let's just follow this arrangement, okay? And let's call the missing side A. So we are required to find A and the remaining 5 trigo function values of angle theta. Now let's solve. First, let's find A. So we have Pythagorean theorem, c squared equals a squared plus b squared. Isolating A, we get a equals square root of c squared minus b squared, where c is 7 and b is 5. Okay, this will result to square root of 49 minus 25. 49 minus 25 is 24. 24 is 4 times 6, where square root of 4 is 2. So we can rewrite this as 2 square root of 6. Okay. Now let's solve for the values of the remaining 5 trig functions. Okay. So starting with sine of angle theta. So sine in this case is just the reciprocal of cosecant, right? So, but based on the triangle, so we have here opposite of angle theta is 5. So we have 5 here, then hypotenuse is 7. Okay. Cosecant or cosine of angle theta is adjacent over hypotenuse. So adjacent in this case is A, where A is 2 square root of 6. So plug into square root of 6 divided by the hypotenuse, which is 7. So cosine of angle theta is 2 square root of 6 over 7. Next, we have tangent. This is opposite side over adjacent. So 5 over adjacent. Adjacent in this case is A. A is 2 square root of 6. So 2 square root of 6. Simplify, rationalize. This is equal to 5 square root of 6. Square root of 6 times square root of 6 in the denominator will result to 6. So 6 times 2, that would be 12. Okay. Next, let's solve for the cotangent value of angle theta. This is, again, the reciprocal of tangent. So we can just take the reciprocal of this expression here. So 2 square root of 6 over 5. Okay. And then lastly, secant. This is the reciprocal of cosine, right? So 7 divided by 2 square root of 6. So rationalize, we get 7 times square root of 6 divided by, so square root of 6 times square root of 6, that would be 6 times 2. So over 12. Okay.